In today's note, what we're looking at is partial and direct variation. And what these terms mean is that they're just terms that we can use to describe our equation of a line and a specific characteristic of it. So just to recall, the independent variable is the variable that does not depend on the other, or in other words, the x value, and we can also think of it as the horizontal. Because again, the horizontal is in today's note, what we're looking at is partial and direct variation. And what partial and direct variation are that they're just terms that we can use to describe a specific characteristic of our equation of a line. So as a review, the independent variable is the variable that does not depend on the other, or the x value. In other words, we can also think of it as the horizontal, because again, the x value goes on the x-axis, which is our horizontal axis. The dependent variable is the variable that depends on the other, or in other words, the y value, and we can also think of it as the vertical, right? Because our vertical axis is the y-axis. So partial and direct variation, they are terms that we can use to describe the relationship between the independent and dependent variable. So what we're going to do is look at two groups of graphs and kind of identify what's similar about these groups and apply it to our two terms. So if I look at group 1, I want to look at these three lines and think about what's similar between the two. Well, first of all, looking at them, the slopes aren't similar because in graph 1 and graph 2, one's positive, one's negative, the third one's back to positive, so it can't be the sign of the slope. It also can't be the actual number for our slope because if we look at all three graphs, they don't have the same steepness. Right? Graph 1 and 3 are definitely one steeper than the third one, and same with the second one. So what's similar about these three lines? Well, if we look at these three lines, what's similar about them is a point that they go through. And that point is the origin. So all three lines pass through the origin. So that is the similarity between them. They all pass through the origin, or in other words, the point 0, 0. Another way you can think about it is they all have a y-intercept of 0. If I look at group 2, again, I'm looking for what's similar between all three of these graphs. If I look at the slopes, again, it's not the slopes. Some are positive, some are negative. Some are steeper than others, so it can't be that. They don't all pass through the origin. However, what is unique is the fact that they don't pass through the origin. They all cross the y-axis at somewhere else or somewhere different. So what's unique about these lines, and we can kind of relate it back to the last group that we looked at, is they do not pass through the origin. So what we can look at, they do not pass through the origin or the point 0, 0, or you could think of it as they all have a y-intercept other than 0. Right? It's another number other than 0. So which group do we think represents direct variation? In other words, which group is there a direct relationship between the x value and the y value, whereas we only apply one specific change to go from the x to the y? In this case, it would be group 1. So that means that our partial variation, where there's partially a relationship, where it's partially being affected by the other one, would be group 2. Now, it may be difficult to kind of understand that, other than just memorizing that direct goes through 0 and partial does not. let's look at some patterns if we go back to what we looked at the beginning of this unit. Direct relationships or direct variation means that if I look at my term 1, 2, and 3, the pattern is going to be directly related to that number. So for example, if term 1 is 2 squares, then I would say term 2 is 4 squares, and term 3 is 6 squares. So there's a direct relationship between the term number and the number of squares. And what that relationship is, if you think about it numerically or algebraically, it's just 3 times my term, or 3n. Now a partial variation or partial relationship, you're looking at, there is a relationship, but it's partial. The y value is being partially affected by the x value. So if I draw my 3 terms again, the difference here, if I draw term 1 like that with the 2 squares, there might also be something like those 2 green squares. So that means term 2, I'll still have my 4 squares, but there's those 2 green squares still sitting there. And term 3, I still have my 6 squares, but I have my 2 green squares there as well. So there is still that relationship where the term number is multiplied by 2 to help me get my blue squares, but I still have to add on those 2 green squares or those 2 constant squares. So that means that the relationship or the pattern would look like 3n plus 2. So that means there's still that direct relationship, or there's still that relationship between the term and the number of squares, but then we have to add something extra on. So it's just a summary for partial variation. Partial variation means that the line does not go through the origin or the point 0, 0, which means it has a y-intercept other than 0, or in other words, it has a constant in the equation. And again, what we mean by that is that your equation would look like y equals mx plus b. So we do see that b value, the y-intercept, that equation, or that constant. Direct variation means that the line does go through the origin or the point 0, 0. So that means that the y-intercept is 0, and it has no constant. Or in other words, if you look at the equation, all you see is y equals mx. The reason that we don't see the plus b is because you'd be adding 0 or the y-intercept of plus 0, which we don't see anyways. We don't show that. So what you should get from this note is, again, just understanding what the two terms mean, partial variation and direct variation, and being able to apply that to a linear relationship, whether you're given it by an equation or whether you're given it by a graph.